Hello, my name is Olga Podlipskaia. We will talk about geometry in this term. Next term, we will talk about analytic geometry and then linear algebra. The first thing I need to say you is that your final score will depend not only the final exam. Yes, in the end of the course, we will have the final exam, but on your work during the whole semester. So you will have 2 tests, 2 homeworks, then you will have theoretical checking, and also we will grade your attendance in practical classes. So during the whole semester you will get your scores, and then we will add all the scores for the semester and for the final exam, and you will have the final grade. In more details, we will tell you about the systems on your practical classes. Well, about our lectures. The first, I guess, 3 lectures will be, well, let's say this is a kind of introduction into our course. We will talk about school geometry. I will remind you the main concepts of school geometry, very basic theorems, and so on. So I think it will be very easy for you, but still I think it is very important to remind about this. So our first lecture will be about points, lines, planes, and triangles. We will define some concepts, then we will formulate a couple of theorems. We will not prove them, today at least, but you will need them to solve the problems on your practical classes. If you have any question, please just ask, or if you in Zoom, please turn your microphone on and ask. You can also use the chat, but actually it is less convenient for me because maybe I see your message in several minutes, but if you ask with your voice, I will hear it at the same time. So if you don't have any organizational questions, I think that we can start our lecture today. Okay? Well, okay. So first of all, let's talk about points, lines, and planes. Well, actually, in mathematics, we need to define all the concepts. But if we are talking about geometry, there are 3 terms, a point, a line, and a plane, that we cannot define. We will define all other terms based on these 3 terms. We can describe them, but we cannot give the strict definition. So the first concept, the first term is a point. And what is it? Well, this is something that doesn't have a length, a width, and a thickness. And if we want to draw a point, if we want to have something to represent a point in a picture, we can use a dot. So we can represent a point with a dot, but it is very important that a dot is not a point, because a dot has size. A point doesn't have size. Then the second undefined concept is a line. Well, what is a line? We can understand it as a path of a point. So imagine that we have a point at this point, and then move in our space, and we have a line. And there can be two different situations. The first situation, here it is when the direction of our movement is when our point simultaneously changes its direction. And in this case, we have this line, and this line is called curved line. And here, our point doesn't change the direction, so in this case, it is a straight line. So two cases. Usually we say just line without any details, curved or straight, and in this case we suppose that this is a straight line. So we can say this line, just line without this word straight. And the final term is a plane, number 3. Yeah, by the way, when we're talking about lines, we can say that they have length. They don't have width or thickness, but they have length. And if we are talking about a plane, for example, this is our blackboard, or this is a surface of a table, or this is a sphere. This is, oh, well, if we're talking about a sphere, this is a surface. And a plane is a particular, in the particular case, it's okay, don't worry. So a plane is a particular case of a surface. A surface has length, and it has width, but it doesn't have thickness. And a plane is a particular case of a surface when we take any 2 points on a surface, then we connect them, and we have this line. We can produce this line, and this line lies on our surface. So in this case, we are talking about a plane. So 3 concepts, points, line, and plane. We cannot give a strict definition, but we need to understand what we are talking about here. Then we can move to the other terms. For example, line segments. Well, what do we have here? We have a line. I can say that we have a straight line, but again, we don't need to say the word straight. And let's choose 2 points on this line. Here and here. Let this point be A, capital A, and let this point be B, capital B. And now let's consider this part of our line, which is between these 2 points. So this part with these 2 points, A and B, is called a line segment or just segment. Or just segment. Well, when we're talking about line segments, we can talk about its measure. And we can say that we can measure this line segment. It means that we can find the length of this line segment. For example, let it be, I don't know, 5 centimeters. So we can say that the length is 5 centimeters, and we write that AB, this is the name of our segment, is 5, 5, okay, 5 centimeters. Well, a segment is very simple concept. It is very simple object, but still we can do a lot of things with this. We can measure it, and we can divide it into 2 or more parts. So imagine this is line segment. Well, let's use another letters, C and D, for example, CD. And let's choose a point inside this line segment. For example, here, this is the point E. A point E. And now we can say that we divide a line segment with a point E. If the lengths of 2 parts are equal, so we divide a line segment into 2 equal parts. We can mark it with these symbols. We can say that this point is a midpoint. And if we draw a line through this point, we will say that this line bisects the line segment. So this is a midpoint, this is a line, and we say that bisects a line segment. Well, then the next object, maybe it is even less complicated than a line segment, it is a ray. Again, we have a straight line and we choose just one point here, point A, and we consider the part of a straight line bounded by with this point. And this part, where is my eraser? This part bounded with this point is called a ray. We cannot measure it because it is infinite, but we need a ray to define the next concept called angle. Well, here we have 2 rays, and these 2 rays start at the same point. This figure is called an angle. These 2 rays are called sides of an angle, and this point, the beginning of our angle, is called a vertex. If we want to name an angle, we can use, for example, Greek letters, alpha, beta, and so on. So we can say that this is an angle alpha, or we can use capital letters. For example, we say that the name of this vertex is A, so this angle is A. So in this case, we say alpha, angle A. Or we can choose 2 points here and here on 2 rays, on 2 sides of our angle. So we will name the angle with 3 letters. Angle A, B, C. And we can measure angles. What is it? We can say that well, a measure of an angle depends on the extent to which we need to rotate one side of an angle until it meets the other side. So this thing. Usually we use degrees to measure angles. Also, we can use another units, for example, radians or something else. But in our course of geometry mainly, we will use degrees. And we know that the whole cycle, this angle, right, the whole cycle of this circle, consists of 360 degrees. So we can divide this circle into 360 parts, and we will get 1 degree. And the measure of our angle is the number of degrees inside it. We can use degrees. For example, we can say that angle ABC is 30 degrees. Yeah, we use this symbol in the right upper corner of our writing. Sometimes we use minutes. 1 degree is 60 minutes. And sometimes we use seconds. 1 minute is 60 seconds. For example, we can say that this angle alpha is, I don't know, 25 degrees, then 20 minutes and 10 seconds. And now we can talk about congruent angle. What does it mean that two angles are congruent? It means that they measure the same degrees. In this case, we write, for example, suppose that this angle has also 30 degrees. So we can write that angle A is equal to angle ABC. So they contain the same degrees. And now I want to draw your attention that doesn't matter what is the length of these parts, the length of sides of an angle. We are interested only in this thing, the extent to which we need to rotate. So the lengths don't matter. There are a lot of concepts concerning angles. Well, the first concept is congruent. Yeah, we can say that two angles are congruent. For example, angle A is equal to angle B. Then the next concept is adjacent angles. It is when we have two angles, but they have the common side, something like this. Of course, they have the common vertex here. This is A, let it be B, C, and D. So this angle and this angle, they are adjacent because they have the common side AC. Oi. Angle DAC and angle CAB are adjacent. If two angles are together 90 degrees, we say that these two angles are complementary. So, for example, this is a so-called right angle. So the measure of this angle is 90 degrees. And if we divide this angle into two parts, let it be A again, B, C, and D. This is a right angle. So angles BAC and CAD are complementary. And if we have a straight line, or we can say that this is a straight angle, or we can divide it into, again, two parts. We will have, again, two angles, A, B, C, and here is D. In this case, the angles BAC and CAD are called supplementary. Then, if we are talking about angles and about their measures, we can introduce the following concepts. So, how to say, let it be kinds of angles. So let's say that we consider an angle from 0 degrees to 360 degrees. So we have how many? 5 kinds. The first kind, called acute angle, acute angle, for example, alpha, it means that the measure of this angle is less than 90 degrees. So alpha is less than 90 degrees. Then the second kind, the second type, is a right angle. It is when the measure of this angle is 90 degrees. Then obtuse angle. The measure is less than 90 degrees, but less than 180. Then, if the measure of an angle is 180 degrees, we're talking about a straight angle. And the final case, when the measure is greater than 180 but less than 360, we're talking about a reflex angle. Well, let's say that, let's draw some pictures. In this case, acute angle, it is something like this. Right angle here, obtuse, something like this, straight here, and reflex is here. So we have 5 kinds. What else about angles? Well, we need to define the very important concept of perpendicular angles or perpendicular lines. So, let's take a line and another line crosses our line. And here we have 4 angles, right? Here, 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 and here. So 4 angles. And here we can say that we have 2 pairs of so-called vertical angles. 1 and 2, and 3 and 4. vertical angles. So vertical angles are angles formed by two crossing lines. And there is one very important property of such angles, that they are equal. Why? Because angles y and 4 together are straight angles, so the measure is 180. 2 and 4 are also a straight angle, so the measure is again 180. So we can say that angle 1 plus angle 4 is 180. Wait. Why doesn't it work? And, oh, not number 2, number 4, sorry. And number 4 plus number 2 is also 180. So from here, we can subtract the second equation from the first one, and from here we'll get that angle 1 is equal to angle 2. Извините, запасных нету стилуса? Не хочет писать. So vertical angles. But sometimes we have a situation when 4 vertical angles are equal. It is when this angle and these and these and these, they are 90 degrees. In this case, we can say that these two lines are perpendicular if it is 90 degrees. We are talking about perpendicular lines. If we have not a line here, but a line segment or just segment, in this case, we can talk about a midpoint of this segment. It is here. And if another line bisects this line segment and this angle is 90 degrees, we say that this line is perpendicular bisector. Is perpendicular bisector. Well, I guess that's it about angles. And let's move to the next concept. Well, actually, this is not the very new concept, but this is how to say the extension of the previous concept. So let's talk about lines, but let's consider a particular case when we are talking about parallel lines. Wait. So parallel lines. So what are parallel lines? How can we define them? Yeah, they never intersect, but also we need to add that they lie in the same plane. because also we have skew lines, maybe you know them. They never intersect as well, but they are not parallel. So yeah, we have two lines lying in the same plane, but they never intersect, however far we extend them. And there are some very interesting properties of such lines. So let's consider the third line here. And when this line crosses two our lines, we have 8 angles. Let it be 1, 2, 3, 4, 5, 6, 7, 8. And all these angles, they have their names. Well, first of all, angles 3, 4, 5, and 6, they are called interior angles. 3, 4, 5, 6. Interior angles. They are inside our parallel lines. And if we are talking 1, 2, 7, and 8, they are outside, so they are exterior angles. By the way, 1 and 4 are vertical, 2 and 3 are also vertical, 5 and 8, 6 and 7. Two angles inside each pair they are equal. Then we can define so-called alternate interior angles. They are 3 and 6 and 5 and 4. So two pairs, they are called alternate interior angles. So they are interior angles, so they are inside our figure, but they lie on the different sides of our third line. Also, we have so-called corresponding angles. So this is 1 and 5, 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Well, corresponding angles. We can say that they lie on the same side of parallel lines and on the same side of our third line. So 1 and 5, yeah, the same side, 2 and 6, again the same side, and so on. And using these pairs of angles, using these angles, we can formulate several principles when we can say that two lines are parallel. Or vice versa, if two lines are parallel, what can we say about these pairs? Oh, principles. The first principle, two lines are parallel if and only if alternate interior angles are equal. Well, this thin if and only if means that if two lines are parallel, it means that angles are equal, and vice versa. If we have equal angles, we can say something about our lines. So two sides. And if we want to prove this statement, we need to prove the both sides. Then, the second case, if we have equal corresponding angles. Again, in this case, we can say that two lines are parallel. And vice versa, if we have two parallel lines, we can say that the corresponding angles are equal. So, two lines if and only if corresponding angles are equal. And the third part is when we consider such angles as 3 and 5 and 4 and 6. We will not give them names, but let's say that let's consider interior angles lying on the same side of the third line. If together they measure 180 degrees, the lines are parallel, and vice versa. If the lines are parallel, the sum of 3 and 5 or 4 and 6 are 180 degrees. If and only if two interior angles on the same side of the third line together let's say are (180 degrees). So three principles when we can say that these two lines are parallel if we know something about angles. Also, we have two more principles, but here we need the third line. For example, this situation. Two lines and the third line. We know that this third line is perpendicular to the both lines. In this case, we have that these two lines are parallel, or vice versa. Or vice versa, if we have two parallel lines and the third line, which is perpendicular to the first line, for example, we know that this third line will be perpendicular to the second parallel line. So we can say that two lines are parallel if and only if a perpendicular to the first line is also perpendicular to the second line. So now let's take a break for 5 minutes. The first case when we have a perpendicular to the both lines, and the second case if we have two parallel lines, and the third line which is parallel to the both lines. And the third line F, and if this line is parallel to the first line, it will be also parallel to the second line. And vice versa, if we have two lines and we have a line which is parallel to the both lines, we can say that these two lines are parallel. So two lines are parallel if and only if a line parallel to the first line is also parallel to the second line. Well, some information about parallel lines. By the way, don't forget to ask questions if you have them. But again, today we have only definitions and some formulations of theorems, so I hope it is not very complicated for you. And the next object, it is final object for today, a triangle. So what is a triangle? How can we define it? Imagine that we have 3 points, and we know that they don't lie on the same line. And now let's consider these 3 line segments. And this plane figure formed by these 3 line segments is called a triangle. These points are called vertices, so this is a vertex. And these line segments are called sides of a triangle. So this is a side, this is a side, and this is a side, and so on. And I think that you know from your school geometry that if we measure 3 angles of a triangle, we will get how many degrees? Yeah. So this is angle 1, 2, 3. (180 degrees). By the way, it means that if we have one obtuse angle inside this triangle, we know that 2 other angles are acute. And if one of the angles is a right angle, again, 2 opposite angles are acute. Okay, so if we're talking about a triangle, we need to say about types of a triangle, right? So we can consider different kinds of types. First of all, we can say something about sides of a triangle. We can measure sides, and there are 3 cases. The first case is when we have 3 equal sides. This side is equal, the length of this side is equal to the length of this side, and is equal to the length of the third side. In this case, our triangle is called equilateral. triangle. By the way, if we want to name a triangle, we need to name its vertices, A, B, C, for example. So we have triangle ABC. We can use this symbol. And in this case, we have AB is equal to BC and is equal to AC. Three sides are equal. The second case, if two sides are equal and the third side has another length, for example, AB is equal to BC and BC is not equal to AC. In this case, we are talking about so-called isosceles triangle. AB is equal to BC, for example. In this particular case, we have more definitions. So A, B, C. These two sides are equal, and this side AC is called a base of an isosceles triangle. Now AC is a base. And the third type, the final, this is the situation when all three sides have different lengths. If AB is not equal to BC, BC is not equal to AC, and AC is not equal to AB, so we have three different sides. And in this case, our triangle ABC is so-called scaling triangle. Scaling triangle. Then, if we are talking about angles, we can divide all triangles into three families. The first family is so-called acute triangles, or sometimes we say acute angled triangle. In this case, all angles of our triangle is less than 90 degrees. It means that all angles are acute. Then right triangle or right-angled triangle. This is the situation when we have one right angle. Again, if in a triangle we have one right angle, it means that the other angles are acute, right? Because the sum must be 180. And the final triangle is obtuse angle or just obtuse triangle. One of the angles is obtuse. And again, it means that other angles are acute, because the sum must be 180. Also, inside triangles, we have several lines, or it's better to say line segments, and they are very important. Let's define them and let's name them. So, lines. special lines of a triangle. The first line, ABC, and this line connects one of the vertices of a triangle and the other side, or let's say the midpoint of the other side. So let's say that this is B1, and this is a midpoint of AC, and in this case, a segment B1 is called a median of a triangle ABC. Median. So our triangle has three vertices. It means that each triangle has three medians. Then another line is a bisector. Again, let's consider a triangle ABC. And now let's consider a line segment BB1. BB1. And let's say that BB1 bisect an angle ABC. It means that these two angles are equal. AB1 and CB1, they are equal. So BB1 bisector. And again, every triangle has three bisectors because every triangle has three vertices. Then, number 3, so-called altitude. Again, our triangle ABC. And now let's drop a perpendicular from B, from one of the vertices, to the opposite side, AC. So BB1. BB1 is an altitude. And number 4, in this case, we are talking about a line, not about a line segment, but about a line. And this is so-called perpendicular bisector. Well, actually, we have already defined perpendicular bisector when we were talking about line segments. But if we are talking about a triangle, we have 3 line segments. So we can also talk about perpendicular bisector. So again, triangle ABC. Let it be a midpoint of AC, B1, midpoint. And let it be a line which is perpendicular to AC. Let it be B1, I don't know, D. So we say that B1D is a perpendicular bisector. Perpendicular bisector of a triangle ABC. And again, we have 3 perpendicular bisectors. And now I want to say something about altitudes in obtuse triangles. So imagine that we have an obtuse angled triangle, ABC. So the angle B is obtuse. And we want to draw an altitude A1. It means that we need to drop a perpendicular from A to BC. And in this case, this point A1 lies not on a line segment BC, but on line BC. Why? Somewhere here. I want to use another color. So A1. Why? Because if we suppose that A1 is somewhere here, yeah? So this is our altitude. This angle is 90 degrees. We know that this angle is, the measure of this angle is greater than 90 degrees, and it means that the sum of angles in triangle ABA1 is greater than 180. But it cannot be so, so an altitude of an obtuse triangle is outside the triangle. It is very important when we need to solve a problem, because we need to draw a right picture. So this is a contradiction. So it is outside the triangle. Well, and if we are talking about isosceles triangle, we have different properties concerning such triangles. And some of the properties are about altitudes, medians, and bisectors. So let's consider triangle ABC. And we know that AB is equal to BC. And we know that BB1 is an altitude. What can we say in this case? We can say that BB1 is also a median, right? And a bisector. And if BB1 is a bisector, what can we say? It is. Yeah, we can say that this is a perpendicular bisector. We can say that this is also an altitude, and this is also a median. And finally, if BB1 is a median, it is an altitude and a bisector. This is when we're talking about isosceles triangles. And vice versa, if we have an altitude and we know that this altitude is a median or a bisector, we can say that the triangle is isosceles, vice versa. So, new principle. If and only if, well, three cases. Altitude BB1 is a median or a bisector, or a bisector, then median BB1 is also an altitude or a bisector. And finally, bisector BB1 is also an altitude or a median. So three cases. Again, if and only if. So if this is true, it is also true. If one of these cases is true, we can say that ABC is an isosceles triangle. Also, inside isosceles triangle, we have four two angles, A and C, so-called base angles. And if a triangle ABC is an isosceles, what can we say about these two angles A and C? They are equal. So if we have two equal sides inside a triangle, we have two equal angles. So again, if and only if angle A is equal to angle C. And if we are talking about equilateral triangle, what can we say about the angles of such triangle? Yeah, they are equal. And the measure of each angle is 60 degrees, right? Great. What can we say next? Now let's talk about some inequalities inside a triangle. So we have some equalities when we're talking about isosceles triangle, for example. Yeah, if we have two equal sides, it means that we have two equal angles. But what about vice versa inequalities? Again, I'm sure that you know all the inequalities, so we will not prove them, but we need to formulate them because today, or maybe not today, when will be your practical classes, you will use them. So you will apply the theorems. So the first inequality, if we have a triangle and we produce one of the sides, we have exterior angle, let it be alpha. And we know that this exterior angle is greater than either of the opposite interior angles. So we can say that alpha is greater than beta and alpha is greater than gamma. So exterior angle is greater than either of opposite interior angles. The first inequality. Then, if we are talking about non-equilateral triangle, we have one side which is greater than another side. And in this case, we can say that an angle opposite to the greater side is greater than the angle opposite to the less. So let's consider this case. This side, let it be A. We know that A is greater than B. And let's say that an angle which is opposite to A is alpha, here is alpha, and the angle opposite to B is beta. So if A is greater than B, it means that angle alpha is greater than beta. So we can say that if one side is greater than another, it means that the angle opposite to the greater side is greater than the angle opposite to the less. Okay, and vice versa, if we have two angles, and we know that one of the angle is greater than another angle, we can say that a side which is opposite to the greater angle is greater than the side opposite to the less. This is number 3. Okay. This is equilateral triangle. Okay, so we see that this angle alpha is greater than this angle beta. This side is A, this side is B. If A alpha is greater than beta, we can say that vice versa, A is greater than B. And the final inequality. Here we talk about sum of lengths of our triangle. We know that if we have a triangle, this is A, B, C, we know that AB is greater than C. We know that A plus B is greater than C, A plus C is greater than B, and so on. So the sum of two sides of triangle is always greater than the third side. So A plus B is greater than C, A plus C is greater than B, and C plus B is greater than A. Triangle inequality, so-called. And by the way, you will meet this inequality in other parts of mathematics. Yeah, but there you will have not strict inequalities, but other greater or equal. But it is when we have three points lying on the same line. And finally, we need to consider some equalities in a triangle. So first of all, we have so-called a sine rule, or the law of sines. If we have a triangle, this is A, B, C, alpha, beta, gamma, and if we consider the fraction A over sine of alpha, this ratio will be the same as B over sine of beta. And this is C over sine of gamma. This is the law of sines. Also, I can say that this fraction is equal to 2r. Here r is a radius of a circumscribed circle, but we will talk about circles next time, I think. But still you can remember it, that this is so. This is the first law. The second law, the law of cosines, or cosines rule. Again, we have a triangle ABC, or let's say that the sides of the triangle are A, B, and C. We use small letters. This is B, beta, gamma, and alpha. So the law of cosines, if we know A and B and alpha, for example, so we know an angle and two sides, and this angle is included between these two sides, we can calculate the length of the third side. So we can say that C squared is A squared plus B squared minus 2AB times cosine, I'm sorry, Alpha is here, gamma is here. So alpha is here, gamma is here. Minus 2ab times cosine gamma. And if we are talking about right angle triangle, so imagine that gamma is a right angle. In this case, cosine of gamma is 0. So we have so-called Pythagorean theorem that d squared is a squared plus b squared in a right triangle. So we can use these facts when we solve the problems. And finally, we need to talk about so-called congruence of triangles. We say that two triangles are congruent if they have equal sides and equal angles. Or it means that we can place one of the triangle onto another triangle. So we say that triangle ABC is equal to triangle A1, B1, C1 if is equal, or these two triangles are congruent if AB is equal to A1, B1, AC is equal to A1, C1, and BC is equal to B1, C1. So the corresponding sides are equal, and the corresponding angles are also congruent. So angle A is angle A1, angle B is angle B1, and angle C is equal to angle C1. This is the definition of a congruence of triangles. But sometimes it is very complicated to check all 6 facts, right? But we have so-called cases of congruence of triangles, and we have 3 cases. We can use them. So the first case, so-called SAS, side angle side. It is when two sides of one triangle and included angle are equal to the corresponding parts of the another triangle. In this case, two triangles are congruent. Well, the second case, so-called ASA, angle side angle. Here we have that two angles of one triangle and the included side, they are equal to the corresponding parts of the another triangle. In this case, we can say that two triangles are congruent. And the final case, so-called SSS, side, side, side. If all three sides of the first triangle are equal to the sides of the second one, it means that these two triangles are congruent. So the triangles are equal. And now let's draw all the situations. Let's consider two triangles, ABC and A1, B1, C1. B1, C1. So, side, angle, side. If AB is equal to A1, B1, if AC is equal to A1, C1, and if included angles are also equal, so this is side, angle, side, these two triangles are congruent. So the next case, ASA. Again, here we have two triangles, ABC and A1, B1, C1. If this angle A is equal to A1, and if, for example, B is equal to B1, and we have two equal sides, and these sides included, right? So this side is common for these two angles. This is ASA case. Two triangles are equal again. And final case, SSS, side, side, side. Again, two triangles, ABC, A1, B1, C1. If this side is equal to this side is equal to this one, and finally, this side is equal to this side. So again, two triangles are congruent. By the way, about ASA case. Actually, if we have that angle A is equal to angle A1 and angle C, for example, is equal to angle C1. Again, we know that the sum of angles in a triangle is 180 degrees. So if A is equal to A1, C is equal to C1, we have that B is equal to B1. So it is not necessary that we have two included sides, two equal included sides. They can be different, right? So we have considered these two equal angles and one this side. Because we know the sum of angles inside a triangle, we can conclude that everything is okay, the triangles are congruent. Well, that's it for today. If you don't have any questions, thank you for the class and see you next week.